Then just a couple of other important functions that we will use. One is element names. So again, these are all part of the help description. If you type help gas, you will see all of these lists and attributes and functions coming up, but I won't do that again and again. So I'll just give you the important functions right here, which you will be using quite often and you should try to remember. So gas dot element names. All right, so now you see it tells you that this phase, this gas phase comprises of 5 elements. And where does it get that information? It gets that information from the input data file, which in this case is GRI30. And let's quickly open GRI30 as well. You see the elements, there are 5 elements, and it has displayed exactly in the same order: oxygen, hydrogen, carbon, nitrogen, and argon. Right now we can I mean, this is a list in Python. This is a list, and so you can do slicing and dicing and all of that. So if we go ahead and I say 1, then it gives me the well, in Python it starts with 0, so the index starts with 0. So 0, 1, 2, 3, 4, and so the first index is for H, and so that is what it tells me. Now if I write, say, what is the first element in the list, then it gives me it shows me oxygen. So the other ones are one of them also is gas dot element index, and here you have to provide the name of the element as well. So here I say hydrogen. So it gives me 1. What does that mean? So here it says that the index for hydrogen element is 1, which is the same thing that we saw here. So when you give an index of 1, hydrogen gets printed. And when you ask, okay, what is the index of hydrogen, then it will tell you using this function, it will tell you that it is 1. Right, and so you can use this for any element in there. Another one is if you want to find out how many elements are there, not just which ones, but how many elements are there. For that, we have n elements. Yeah, so now it says that there are 5 elements. Then we can do something similar with species as well. So you see in the GRI data file, let's go back. So all of these are species, right? If you want to know how many species are included in that data file, all you have to do is write n species. 53, right? So there are 53 species in that data file, which is quite a big number, I would say. Then what else? Let's look at what all different species are there. For that, there is another attribute called species names. Species names. Oh, see, there's so many of them. 53. So these are all the 53 species. And this is a list. Anything inside a square bracket in Python is a list. And so we can again, we can call out, okay, tell me which species has the index number 2. Says O. And if you see here, 0, 1, 2, that's O, right? So that's so you can just call, if you want a particular species, you can just call them by the index. In addition to that, you can also find out what is the index for a particular species. So gas, that's species index. And now if I provide the name of the species, which is O, this is the other way around. So it is telling me 2. So these two commands are opposite of each other. But this one especially is very, very useful. Element index, species index, these are all very useful commands. So finding index in Cantera comes in pretty handy, and you will see as we go ahead. Then if we want to calculate, or if we want to find the mole fraction, so one way was to look at the mole fraction dictionary, which will give you the mole fractions of all of the 53 or whatever species. If they have non-zero mole fractions, and it'll give you the entire list. But if I want to find the mole fractions or mass fractions of a particular species, so for example water, then what do I do? Let's see what is the species index for water. 5. Okay, so then in that case, let's see, what do we have? Oh, sorry, we just have methane and oxygen, and that is why it was showing 0. So let's find out the species index for methane. Okay, 13. So 13 is the species index for methane. Now, if I want to find out the mole fraction of methane, how many mole fractions are there of methane only? I do not want to see the mole fractions of oxygen or any other species. Then I just have to type gas dot x, which is a symbol for mole fractions, and in braces I just type the index of the species, 13, and it shows 0.199 to 0.2, which is what you see here as well, 0.2. Now a shorter route would have been to, instead of finding the index and then giving the index, just have everything in one line. So instead of providing 13, I will write gas dot species index CH4, right? The same thing. So this is also quite important, I would say. Then same thing with the mass fraction. If you want to find the mass fraction, instead of x, just type y, and you'll get the mass fraction instead of mole fractions. And then finally, one last thing is to find out the molecular weight of a mixture. So here we have a mixture of methane and oxygen. How do we find the molecular weight of this mixture? One way obviously is to do the hand calculations, but that's cumbersome. So let's do it the Cantera way. There is already a function in Cantera which is called mean molecular weight. So if I just type gas dot mean molecular weight, all right, so that's 28.8. That is the mean weight of this particular mixture at this point. So you see how Cantera makes your life really easy. If you have to do a bunch of combustion related calculations, Cantera can be very, very, very useful, very helpful. And this is just the start. So you'll see how to develop more complex scripts and programs. This is one small thing has come to my mind, and which is to find out molecular weights of particular species if you want to. How to do that? Sorry. So what you do is, for example, the same, let's use the same example of methane. So we say gas dot molecular weights 13, right? So we have, it shows 16, which is the molecular weight for methane. 13 is the index for methane in this entire list of species, And again, what we can also do is instead of providing, instead of finding out the index for methane and then providing the index, we can just write the whole thing in one single line. So I'll just copy this part and provide it here. Right, so same thing. So that was it for this lecture. And the functions and the attributes that we saw here are immensely important, and they form the basis of many of the scripts and techniques that you will see in future videos. So do remember to practice some of these, look at the help files, check on them online, and I'll see you in the next lecture. Thank you.